For the Markovian property, let's take a look at the second example. Trying to imagine the electronic devices we are using every day, such as computer, keyboard, and mouse. And let's draw a Causal diagram here. And notice that the Markovian property tells us that when we control sort of like the junction in the system, then which is bad that the objects on the end of the arrow should be irrelevant. And to put it into the example, that is when you are turn on the power button of the computer, then the keyboard and mouse should working together. And if you turn on the button, they will shut down together, right? But what if there's a third situation that is sometimes the computer might have something wrong, which is the keyboard and the mouse didn't work even if you have already turned on the button. So remember, the Markovian property tend to tell us that the working states of the keyboard and mouse should be irrelevant, right? But you see here, given the first and the third situation, when you have a button is on, the keyboard and mouse can sometimes working together and can sometimes shut down together. So you might get a sense like, oh, the keyboard is more likely to working normally if simultaneously I've observed a mouse is working normally as well. So how could this happen? Well, that brings us to the topic of this line, which is notice that the causal Markov framework doesn't hold in what we call the interdeterministic system. So what is such a system? So see here, normally when you turn on a button, we expected that the keyboard and mouse will absolutely working together, right? But now the truth is, when you have the button on, there are essentially two of the situation that you can observe. So that will make a system to be not deterministic, and the Markovian property will not hold in such a system. But fortunately, the Markovian property will hold again if we go into a detailed versions of the system, or we say a micro system. That is, remember, just now I say there might be something wrong inside the computer, right? So now if you draw the diagram like this, and you show explicitly the inside electronic circuit like this, and if you control the circuit here, there's not something ambiguous about the system, right? It's just, this the 0 and 1 binary system in the computer system, right? Okay, so the point of this line is that the exact property of the causal Markov condition is the conditional independence, right? And it turns out that the Markovian property is such a general property, and even sometimes it appears to be unsatisfactory, but it will hold it again in a micro system, in the detailed versions of the system. There's not something wrong about the Markovian property itself. It depends on how you describe the system.